Welcome to this introductory video about cost-benefit analysis in the context of environmental economics. Our goal here is to present the fundamentals of cost-benefit analysis so you can use this tool in your daily work, especially if you work in conservation-related fields. In simple terms, the cost-benefit analysis, or CBA, is used in the environmental context to evaluate projects or policies related to direct environmental improvements, like creating a protected area or projects that will impact the natural environment, such as establishing new protected areas, constructing a road or a dam. By the end of this video, hopefully you will understand what a CBA is, why conduct a CBA, what the components of a CBA are, how to conduct a CBA analysis, and it's really important to understand right away that a CBA is a decision support tool. It helps us weight the positive outcomes against the negative ones. However, as you will see, there are some known limitations in using this tool, especially in environmental economics, where not all benefits and costs can or should be monetized. Okay, so now let's delve into the heart of our topic. A cost-benefit analysis, or CBA, is a form of data-driven decision-making that involves counting all the costs and benefits of a project or decision and subtracting one from the other to assess its overall value or its net benefit. In practice, this means identifying and quantifying every possible cost, such as construction costs, maintenance, disruptions to the local environment over the project lifetime or an established time horizon. Similarly, we count all potential benefits like increased revenue, improved quality of life, environmental gains, and long-term sustainability. Once we have counted all the costs and benefits, we subtract the total costs from the total benefits. If the benefits outweigh the costs, the project is considered worthwhile. Conversely, if the costs outweigh the benefits, it might be wise to reconsider the project. So why is cost-benefit analysis or CBA particularly important in environmental economics? Well, decisions in this field often involve trade-offs between economic development and environmental preservation. Take, for example, the decision to pave or not a road in the Amazon forest. On one hand, a road could potentially lead to job creation, improve connectivity, generate some economic benefits, and reduce transportation expenses, for example. However, on the other hand, the pavement of a road in such an important and pristine place such as the Amazon rainforest could result in several environmental impacts, increase illegal activities, increase violence, and also contribute to the spread of disease. So the answer to the question, should we pave this road, is not as straightforward as one would imagine. However, some might argue that in such pristine places, roads should not be built regardless of their potential economic benefits. But that's like another discussion. The key message here is that CBA can be a fantastic tool because it allows us to systematically evaluate these trade-offs involved in various environmental projects. And in doing so, it helps policymakers, business, and environmental organizations make informed decisions by comparing the economic, social, and environmental impacts of different options. So, for instance, when evaluating conservation projects, CBA helps us understand the cost of preserving natural habitats, such as the expenses of land acquisition, management, and enforcement, against the benefits like biodiversity conservation, carbon sequestration, and recreation opportunities. Another example is the case of pollution control measures. CBA theory will allow us to weigh the cost of implementing pollution reduction technologies, regulatory compliance, and monitoring against the benefits of improved air and water quality, reduced health risks, and enhanced ecosystem service. The challenge here, as you will see once you start conducting your own CBA, is that it can be challenging to calculate the monetary value of certain costs and benefits, such as enhanced ecosystem service. You need to have a clear idea of all costs and benefits you want to consider, but also understand that not all will be part of the CBA. It's crucial to think about how the exclusion of these costs and benefits will affect the results. So you have a sense if the final value obtained is like underestimated or overestimated. By systematically evaluating these costs and benefits, CBA provides a comprehensive framework to ensure that resources are allocated efficiently and that the chosen projects or policies maximize overall social welfare. In summary, why cost benefit analysis? Because it's a tool that helps us navigate the potential trade-offs existing in environmental projects or policies. But above all, I believe that the main advantage is that it provides you with a value that is easily communicated with people from different backgrounds. Okay, so now let's break down the components of an environmental cost benefit analysis into two main categories, costs and benefits. First, let's look at the different types of costs involved in environmental projects. We have direct costs. These are the immediate expenses required to execute a project. Examples include the initial costs associated with construction, such as materials, labor, and equipment. You have like indirect costs. These are the secondary expenses that may not be obvious. Examples include administrative expenses, overheads, and opportunity costs, meaning the benefits foregone by not investing resources elsewhere. And finally, the external costs. And these refer to negative side effects that a project might have on the environment or society. We usually call these costs negative externalities. Examples include pollution, habitat destruction, and social displacement. It's essential to identify and try our best to quantify all these costs to have an accurate assessment of the total expenses associated with the project. Okay, so now let's look at the different types of benefits that an environmental project might generate. We have like a direct benefit. These are the immediate positive outcomes of a project. Examples include increased revenue, job creation, and improved infrastructure. Indirect benefits, these are the secondary positive outcomes. Examples include increased property values. And we have also the external benefits. These are the positive side effects that a project might have on the environment or society. In this case, positive externalities, we call these positive externalities. Examples include biodiversity, conservation, carbon sequestration, and improved air and water quality, enhanced community well-being, and better public health. And just like with the costs, it's crucial to identify and quantify all these benefits to understand the total positive impact of the project. By evaluating these costs and benefits, CBA provides a comprehensive framework to ensure that projects or policies are chosen in a way that the overall benefits, the net benefits, are greater. No, I'm sorry, the overall benefits are greater than the overall costs, or like the net benefits greater than zero. So other two important components of a CBA are time horizon and discount rate. Time horizon refers to the period over which we analyze the costs and benefits, and the discount rate helps us calculate the present value of future costs and benefits, accounting for the fact that money today is worth more than money in the future. And it's important to note that if the costs and benefits identified previously are nominal, meaning that their values consider inflation, then the discount rate should also be nominal. Otherwise, a real discount rate should be used. Okay, so now that you understand the theory, let's move to a practical exercise. We'll conduct our own cost-benefit analysis using a hypothetical example and a spreadsheet that I created, which you can download for free at the link provided below. Um, there is also like another video in which I explain more detail this spreadsheet and how you can use and adapt it to conduct your own CBA. Okay, let's start. Suppose we are the government and we want to create a protected area to conserve biodiversity, protect endangered species, and promote ecotourism. The location we are thinking about is pristine, but it has some agriculture and logging activities inside it. So we start with some basic data, the nominal discount rate and the inflation rate. Next, we need to collect the data on the cost and benefits associated with two scenarios, one with the protected area and the other without it. We aim to understand the difference between the net benefits in each scenario. So let's start with the costs. Here we have hypothetical costs, including one-time costs like land acquisition, infrastructure development, and initial habitat restoration. We also include annual or recurrent costs over a 15-year period, such as maintenance costs, administrative expenses, and opportunity costs for alternative land uses. Now let's look at the benefits. Similarly, we have a one-time benefit like enhanced property values, and we also have recurrent benefits over the 15-year period, including ecotourism revenue, job creation, and carbon sequestration. Just remember that job creation and carbon sequestration must be monetized to be included in the CBA. Using this spreadsheet, which you can download and adapt to your own context, we calculate the net present value or net present benefit for each scenario. In this hypothetical example, we find that creating a protected area is a wise investment as it generates a net benefit greater than the current situation, that is, without the project. And the net present value with the project exceeds the net present value without the project by about $4.4 million. With this spreadsheet, we can also evaluate the net benefit for each stakeholder, which enhances transparency and helps identify the distribution of costs and benefits among stakeholders, which is like very important. Under this hypothetical example, the public sector, and here we use this like nomenclature as a proxy for government, bears all the costs. In this scenario, without the protected area, society bears most of the costs. But please remember that this is all hypothetical. Okay, so now you know what a CBA is, why we use it, how we conduct a CBA, and the remaining thing for you to learn from this introductory lecture is to understand that while cost-benefit analysis is an important decision-making tool, it comes with its own set of challenges and limitations. One of the first challenges is the difficulty in predicting all variables, while CBA helps outline the projected costs and benefits of a project. Um, it is challenging to account for all the factors that might impact the outcome, especially in the long term or long term horizon. Another common challenge, which we have already mentioned here, is accurately quantifying all the identified costs and benefits. In many environmental projects, certain costs and benefits can be difficult to measure in monetary terms. In this case, we should use environmental valuation techniques to help us. Sorry, excuse me. But this is like a whole new video. In addition, CBAs are sensitive to fundamental inputs such as the time horizon and the discount rate. I talk more about this in my other video in which I go over like the spreadsheet. But it's important to have in mind that when conducting a CBA, it's good practice to change these parameters one at a time to see how the results change. Finally, CBA can sometimes oversimplify complex decisions, although we try our best to capture like everything. Um, Environmental projects often involve multiple stakeholders with diverse interests and values. So relying solely on CBA might overlook important social, ethical, and ecological considerations that cannot be expressed in dollars, for example. Having said that, CBA is for sure a valuable tool, but it should be used alongside other decision-making frameworks to ensure like a comprehensive evaluation. And the process of conducting a CBA should always be transparent, with all the parameters and assumptions explicitly defined in a report or like a spreadsheet. So to conclude, and that is my last slide, we have covered a lot in this video. So let's quickly recap the key points. First, we defined cost-benefit analysis and explained its significance in environmental economics. We discussed how CBA helps us evaluate projects and policies by comparing their costs um, and benefits, and also presented some limitations of like the CBA. So with that, I conclude this first lecture. Thank you very much for watching this video.